You know, we're surrounded by software from the second our alarm goes off in the morning. It's everywhere. But behind those simple little icons on your screen is this huge, incredibly complex world. So today, we're going to peel back the layers and really figure out what software is. From the simple app in your pocket all the way to the AI that is literally shaping our future.
So let's kick things off with a question you've probably never even stopped to think about. We throw around the words app and application all the time, right? But are they really the same thing? Well, the answer to that is kind of our secret handshake, our entry point into understanding this whole landscape.
Okay, so here's the deal. Even though we use them interchangeably, in the tech world, there's a pretty clear line in the sand. An app is usually a simple, single-purpose program, something on your phone, like a weather app. But an application, that's a whole different beast. We're talking about a complex piece of software with tons of different functions that's often absolutely critical for a business to even run. Think about it. If your weather app breaks, it's annoying. But if a company's core application goes down, work just stops.
Now, this little distinction between a simple app and a complex application, it actually hints at a much bigger, more fundamental split in the world of software. It's really the difference between the software that runs the computer and the software that we run on the computer. First up, you've got system software. The best way to think about this is like the foundation and the hidden guts of a house. The plumbing, the electrical wiring, the concrete slab it's all built on. This is your operating system, Windows, Mac OS, Linux. It manages all the computer's memory, its processes, the hardware. It's absolutely essential for anything to work, but we almost never interact with it directly. It just works, hopefully. And then, sitting right on top of that foundation, we have application software. Now, these are the things we actually see and use every day. This is the furniture and the appliances in the house. Your web browser, your music player, that spreadsheet program you use for work. They're all applications designed to help you, the user, get a specific job done.
And that right there is the core of their relationship. System software's whole job is to manage the machine itself. It's totally essential, and it's written in these really complex, low-level languages close to the hardware. Application software, on the other hand, its job is to serve us, the users. A computer can turn on just fine without it, and it's usually written in high-level languages that are a lot closer to human language.
Okay, so we've got these applications that we use to do stuff. But how do we, get them? Today, especially for businesses, there are two main ways they get access to their most important software. So let's break down the two dominant models. First, you've got on-premise. This is the traditional way, right? A company buys a big, expensive software license and installs it on its own servers in its own building. It's a huge upfront cost, and you need an IT team to manage it, but you get total control. Then you've got cloud software, or SaaS, software as a service. This is the total opposite. You just pay a subscription fee, you access it online, and the provider handles all the maintenance, the updates, everything. It's all about flexibility, but you give up a bit of that direct control. All right, so beyond how you get the software, there's an even deeper, almost philosophical question here. Who controls its fundamental blueprint? Who actually gets to see and maybe even change the source code itself? And this question basically splits the entire software world right down the middle.
On one side, you have proprietary software. Think Microsoft Office. The source code is a closely guarded trade secret. It's owned and controlled completely by the company. You buy a license to use it, but you have no idea how it's made, and you definitely can't change it. But on the other side, you have open source software, like the Firefox web browser. Here, the code is totally public. A global community of developers collaborates to build and improve it, and its license actually encourages you to modify it and share it freely. Two completely different worlds.
And this whole idea of control brings us to the deepest, most complex part of our journey today. We've talked about who controls the code, but what about legal ownership? Because the rules that govern who truly owns a piece of software, well, they're surprisingly weird and not at all what you'd expect.
So let me ask you this. When you pay for a program, do you own it in the same way you own a book or a chair? The answer, almost 100% of the time, is a big fat no. You see, you're not actually buying the software, you're buying a license. It's basically a permission slip from the owner that gives you the right to use their software, and only under their very specific rules.
Now, to really wrap your head around how software is legally protected, you kind of have to understand how it's born. It's this three-step transformation, really, that takes a pure idea and turns it into something a machine can actually understand and run. Everything, and I mean everything, starts with an idea. It's a method for solving a problem. In computer science, we call this an algorithm. It's the abstract blueprint, a set of rules for getting something done that isn't tied to any specific programming language. It is the pure, raw concept at the very heart of the software. Okay, so next, that abstract idea, that algorithm, gets translated into a specific language that a human programmer can read and write. This becomes the source code. Let's use a baking analogy. The algorithm is the idea of a chocolate cake. The source code is the detailed, step-by-step recipe, written out with exact ingredients and instructions that a baker can actually follow. And for the final step, that human-readable source code gets put through a process called compiling, which turns it into machine-readable object code. This is the final string of ones and zeros that a computer's processor actually understands and can execute. The recipe has been baked, and this is the final functional cake that the computer can now serve up.
And this is where the legal stuff gets really specific and really important. Copyright protects the expression of an idea, the literal text, just like it protects the words in a book. So, copyright covers your source code and your object code. A patent, however, does something different. It protects the underlying process or method, the algorithm itself. It protects the invention. So you copyright the specific text of your recipe, but you patent the brand new, inventive method of baking itself. See the difference?
And here is the perfect real-world example. This is from Google's original game-changing search patent. Now look closely. They didn't patent their lines of code. No, they patented the method of weighting the relative importance of web pages. They patented their core algorithm, that inventive idea that was at the heart of their entire software. That's the power of a patent. And that, believe it or not, brings us to right now, to the future. All of these concepts we've talked about, system versus application, the cloud, open source, intellectual property, they are all crashing together on the next great frontier of software, artificial intelligence. I mean, AI software is already completely transforming every industry you can think of. It's helping doctors diagnose diseases faster, it's powering self-driving cars, it's personalizing education for students, and it's detecting financial fraud in real time. This isn't just another application, it's a totally new kind of software that can learn and adapt all on its own.
And this leaves us with this huge, fascinating, unanswered question. We've just established that the inventive method, the core idea behind software, can be patented and owned by a person or a company. But what happens when an AI starts to create its own novel algorithms, solving problems in ways we never taught it, in ways we might not even understand? Who's the inventor then? Who or what gets to be the owner? That is the puzzle we are all going to have to solve next.